Hello and welcome to this video about programming concepts in SciScan. My name is Bruno Pichler and I'm the lead author of SciScan, the scientific and multiphoton image acquisition software. I'm going to demonstrate to you today how easy it is to interface SciScan with your custom software. If you're already a little bit familiar with LabVIEW, then you'd probably be a little bit confused about what you see when you look at the block diagram here. All these elements on the block diagram are not connected to anything, which is unusual in LabVIEW. Normally all these elements should be wired up to LabVIEW functions, but here they're just sitting there on their own and they're not connected to anything. So in SciScan we use reference numbers for all of these front panel elements, and we use these reference numbers elsewhere. So what do I mean by elsewhere? We have a number of different modules that all run as top-level VIs in parallel. So if you look at your settings file, let me just bring that up for you quickly. If you look at the settings file, in this case for a resonance scanner, you'll find that you'll have a number of modules here. There's a number of required modules and a number of optional modules that depend on your different hardware settings. So everything that's listed here under modules will be loaded up when you're starting SciScan. So if I start SciScan here, you can see that it's starting to load all these modules, and then all these modules will be running in parallel. How do these parallel modules communicate with each other? This is all done by means of a functional global variable. We typically refer to it as a functional global variable when data is stored in shift registers in a single iteration loop. So as you can see here, there's a while loop which is immediately terminated at the first iteration, but all the data that gets passed in and gets passed out will always get stored in these shift registers. And in our case, this data is actually stored as a variant data type. So if you look at this data type here, that's a variant data type, and that means that this data type can hold all other data types, so strings, arrays, numeric data types, images, reference numbers, whatever you put in there, it'll automatically get stored in that variant data type. And because of this general usability, we call this a generalized functional global, or GFG. And this VI that you see here is at the core of our GFG. We use this everywhere in SciScan. Anything you see in SciScan, any of these front panel elements, sliders, numbers, the states of buttons, everything is stored in this generalized functional global. We also store all the reference numbers to all of these buttons. We store reference numbers to all the images. Everything is available in this generalized functional global. And that means we have access to all of this from any standalone VI. And that's what makes it so easy for you to write your own VI and control whatever you need to control within SciScan. So how do we actually access the data that is stored in that GFG? And to show you that, I'm just going to write a little example VI that makes use of that GFG to read some of the settings in here. And you can see that SciScan is already running, and I don't even need to stop it. I don't even go in there. You don't even need to understand any of the code that's written in there. All you're going to do is just write your new VI, use this GFG core VI as a sub VI on that block diagram here, and let's say you want to read out what the laser power is. So all you need to do is give the variable name here. The variable name for all these front panel elements is the same as the title of that front panel element. So in this case it will be laser power, and then I would need an indicator, obviously. In this case it will be a variant out, and if I set that laser power to whatever value in SciScan, in my new standalone VI, I have access to that value now. If I read that out, it'll show me it's at 30.5, and if I change that value to something else, if I read that again, it has access to that value. Now, this also works the other way around. So now, instead of reading it out, I want to set that value. So to do that, I need to change the action here. So the action is now, I want to set that variable. So I'm going to change this to set. And let's say I have a value here that I want to input. Let's say, for example, I want to set the laser power to 15. I'm going to wire that here to the variant in. I'm going to run that. And you can see on the main SciScan user interface, the value gets updated. I can do that again, show you that with a different value. You'll see that the value gets updated when I change the setting from an external VI. So as you can see from this quick demonstration, it's very easy to read values from SciScan and to write values into SciScan. For example, if you have the need to control the stages from your own custom-written software, if you want to control the PMT gain, the laser power, zoom values, whatever you see on the front panel, whatever you can manipulate manually as a user, you can also manipulate programmatically from a standalone VI. Now, there's actually a lot more flexibility in that GFG than meets the eye at first. What you can do with this is, for example, get reference numbers for all of these front panel elements that you see here. So if we use this polymorphic VI to obtain, say, a reference number to that laser power button, we can choose here what we want to get out of that GFG here as a reference number, in this case obviously a front panel reference. So we will then need to unbundle those and choose the reference number for a knob reference. And we can then use property nodes to have access to anything that front panel element does. So we change this to right. For example, if I was to change the visibility of this button, I can set that to invisible, and bang, it's gone. I haven't even stopped SciScan. I have full control over any of these front panel elements from a standalone VI that I haven't even saved yet. So that is quite convenient in terms of you don't have to do any of the what I tend to call forensic programming, trying to understand all the code that someone else has written. You have direct access to anything you see here, and anything that you can do manually, you can do programmatically, and obviously much more, as you can see here, with making invisible of a front panel element. Another functionality in the GFG is that it actually generates events whenever one of the variables is changed. So that means you can listen for events to occur whenever something changes in SciScan, whether it's a variable or a front panel element or a frame count in the background. Anything that happens will happen in terms of a change of a variable, and that will generate an event that you can capture in your standalone VI. So let me quickly show you how to do that. You need the reference from that core GFG VI. Then you want to register for an event. Obviously, you're going to need an event structure. Now I'm just going to create a case here to handle the stopping this loop around the event structure. So I'm going to add an event case here. Whenever that value changes, it's going to stop the loop here. But more importantly, I'm going to wire this event registration to my event case here, and now I can add an event case that will listen for a user event. And in my case, a user event will be any variable change in the GFG. And you can see here that it will tell me the source VI, so it will tell me which VI has generated this change in the GFG. It will tell me which variable has been changed. It will tell me the data type of that variable, and obviously the data itself stored in this variant data type. So I can now listen for specific variables that I'm interested in. For example, say I have a use case where I need to monitor what the zoom factor is. Whenever that zoom factor changes, I want to get an update of what the new zoom factor is. So all I need to do is wire that variable name to my event case here. Whenever the value for that zoom variable changes, I'm going to get automatically alerted here through that user event, and the value will get updated in my new standalone VI. So let me just demonstrate that quickly to you. Obviously I need to run that VI, and now whenever I change that zoom factor here, you can see that that change here automatically shows up here in my new VI. Despite me not having changed anything inside SciScan, I've only written another standalone LabVIEW VI that listens for these events. Now, I hope that this demonstrates a little bit how easy it is to interface standalone VIs with whatever is going on in SciScan, and that should help you to integrate any other workflow software that you have or that you're planning to write that will help you to automate your experiments. Even if you have your workflow software in something like Python or MATLAB or C++ or anything else, there's always an option to interface those with LabVIEW, for example, through ActiveX. And we can then, within LabVIEW, make use of this GFG to have access to all the variables that are in use behind the scenes in SciScan. You have access to all the front panel elements. And if you have any questions about how to make that work in your specific experiment, don't hesitate to get in touch with Scientifica and drop us an email, and we'll be happy to talk you through more of this. This concludes the video. Thank you very much for your attention.